The agenda of this section, as already stated, will be to refresh our memory on how to do linear regression in scikit-learn, attempt to use linear regression for classification, show you why logistic regression is a better alternative for classification, brief overview of probability, odds, exponentials, logs, and log odds, explanation of the form of logistic regression, explain how to interpret logistic regression coefficients, demonstrate how logistic regression works with categorical features, and then finally, comparing logistic regression with other models. Let's get started with the first part. Predicting a continuous response. We will be pulling data from a well-known machine learning databases repository, and our dataset will be called GLASS. Since it does not have column names, we have written down all the column names by hand. We are going to read that CSV file through the URL using all the column names that we have hand encoded, and we'll use the ID column as our index. Once done, we'll sort the values by the AL column and we'll look at our dataset. And there it is. We have successfully loaded our data that we are going to work with for the rest of this section. So let's go through some of the burning questions as usual and try to solve them using pandas and scikit-learn. Pretend that we want to predict Ri and our only feature is AL. How could we do it using machine learning? We could frame it as a regression problem to start things off, and then using our existing linear regression knowledge, we could try using AL as the only feature and Ri as the response. And how would we visualize this model? We'll create a scatter plot with AL on the x-axis and Ri on the y-axis and draw the line of best fit. Using the Seaborn library, we've taken a shot at creating a scatter plot with Ri and AL and drawing the line of best fit. Now, how would we do the same thing without Seaborn? Let's try using matplotlib and pandas to do the same thing. So we use the dot plot function of pandas, specify the kind of scatter with our x's and y's specified, and we have the scatter plot. Equivalently, if we wish to do the same thing using native matplotlib, then this is what we have to do. We would have to do plt.scatter with the x and y specified. We are specifying the x label and y label, and plt is just a matplotlib object that we have imported at the start of our notebook. So typically we try and fit a linear regression model by using scikit-learn's linear regression object. We specify the feature columns as AL because we want to start simple, specify that as X, the Ri column as Y, and then we fit X and Y. Once done, we will try to predict the values of Ri based on the values of AL. And for that, we try to use a .predict function. We encode those predictions in a column inside the dataset itself called ri_pred, and you can see that once we display the head of the dataset. So if we now were to plot what these predictions look like on a straight line, that is the line of best fit, we will try using matplotlib to generate that line. So in addition to our scatter plot, we also plotted a red line which contained the Ri pred values.